Hey everyone, and welcome back to the channel. Today, we're diving deep into a topic that is fundamental to so many of the low-voltage systems we interact with every day, Class 2 circuits. If you've ever wondered what makes the wiring for your smart thermostat, doorbell, or security system different from the outlets in your wall, you're in the right place. We're going to break down what Class 2 means according to the National Electrical Code, or NEC, why it's so important, and how it makes our lives safer and installations easier. So, let's start with the basics. What exactly is a Class 2 circuit? The official definition comes from Article 725 of the NEC. In simple terms, a Class 2 circuit is a power-limited circuit. The key word here is limited. These circuits are specifically designed from the ground up to minimize two major risks, the risk of electrical shock and the risk of a fire. By strictly limiting the voltage and current, the NEC deems these circuits safe enough that they don't require the same heavy-duty wiring methods as standard 120-volt power circuits. This is a huge deal, and it's what allows for simpler, faster, and more cost-effective installations for a whole range of devices. Let's get into the specific numbers that define a Class 2 circuit. The magic of Class 2 lies in its low energy levels. Typically, the voltage on a Class 2 circuit will not exceed 30 volts AC or 60 volts DC. This is a level that's considered safe from a shock hazard perspective for most situations. But voltage is only half the story. The other critical component is power, which is measured in volt-amperes, or VA. A Class 2 power source is limited to a maximum output of 100 volt-amperes. Think of it like a pipeline. The voltage is the pressure, and the current is the flow rate. Even if the pressure is low, a huge flow could still cause problems. So, the NEC limits the total power to prevent that. In terms of current, you'll often see a cap around 8 amps or less, but this is tied directly to the voltage and the 100 VA limit. A crucial requirement is that a Class 2 circuit must be fed by a listed Class 2 power source. This isn't just any old transformer or power supply. It has to be a device that has been tested and certified by a recognized agency like UL to meet the strict energy limiting requirements. These power sources are designed to be inherently limited. This means that even under a short circuit condition, the power supply will automatically limit its output to a safe level, preventing overheating and potential fires. It's a built-in safety feature. Some power supplies achieve this with an internal fuse or a self-resetting PTC, while others are designed so that their windings simply can't produce dangerous levels of energy. This inherent protection is the bedrock of the entire Class 2 system. Now, where do you actually find these circuits? The answer is everywhere. You probably have dozens of them in your home or office right now. The most common applications include your HVAC control system. That little wire running to your thermostat? That's almost certainly a Class 2 circuit. The same goes for modern video doorbells, residential security system sensors and keypads, garage door openers, and many landscape lighting systems. Even some types of low-voltage LED lighting, especially under-cabinet lights or tape lighting, are powered by Class 2 drivers. The reason they're so popular for these applications is that the wiring is so much more forgiving. You don't need to be a master electrician to safely run a thermostat wire. This brings us to one of the biggest benefits of Class 2, the wiring advantages. Because the risk of shock and fire is so low, the NEC allows for much simpler wiring methods. Instead of needing to run wires inside rigid metal conduit or armored cable like you would for a standard power outlet, Class 2 circuits can often use less expensive, more flexible cables, like a CL2 rated cable. The CL2 designation means it's rated for Class 2 use. In many cases, you can run these cables without any conduit at all, stapling them directly to framing members, which saves a massive amount of time and material. This is a game changer for installers. However, there are still very important rules you have to follow. The most critical rule is separation. Class 2 circuit wiring must be kept separate from non-power limited circuits, like your standard 120-volt or 240-volt wiring. You can't just run your doorbell wire in the same conduit as your lighting circuit. Why? Because if the insulation on the high-voltage wire were to fail, it could energize the low-voltage Class 2 circuit with a lethal amount of power, completely defeating its safety purpose. The NEC has specific rules about how much separation is needed, or what kind of barriers are required if they have to be in the same enclosure. Generally, you want to maintain at least a quarter-inch of separation, or use a fixed barrier. Another interesting aspect is overcurrent protection, like fuses or circuit breakers. On a standard circuit, you have a breaker in your panel to protect the wires from drawing too much current and overheating. But for Class 2 circuits, Overcurrent protection on the load side of the power supply is not typically required. Remember how we said the power source itself is inherently limited. That built-in limitation serves as the protection for the entire circuit. The power supply simply cannot deliver enough energy to damage the correctly sized wire. This simplifies the design and reduces the number of components needed for a safe installation. Now, it's important not to get confused with a couple of similar-sounding terms. You might hear about Class 3 circuits, which are also covered in Article 725 of the NEC. Class 3 allows for slightly higher voltage and power levels than Class 2. Because of this increased energy, it's considered to have a slightly higher risk, and so the wiring requirements are a bit stricter. While still a low-voltage circuit, it doesn't offer quite the same ease of installation as Class 2. Another point of confusion can be the term Class 2 with Roman numerals. A Class 2 power supply is not the same as a Class 2 circuit. The Class 2 designation refers to the construction of the power supply itself. It means the device is double insulated, so it doesn't require a safety connection to an equipment ground. You can often recognize these by their 2-prong plugs instead of 3-prong. A power supply can be both a Class 2 device and a Class 2 power source, but the terms refer to completely different safety standards. One is about insulation, the other is about energy output. So, let's recap the key takeaways. Class 2 circuits are all about safety through energy limitation. They operate at low voltages, typically under 30 VAC or 60 VDC, and are capped at 100 volt-amperes of power. They must be powered by a listed, inherently limited Class 2 power source. As always, while this overview gives you a solid understanding, the National Electrical Code is a complex, legally binding document that gets updated regularly. For any actual installation, it's absolutely critical to consult the latest edition of the NEC and always follow the manufacturer's specific instructions for any listed equipment you're using. Compliance is key to ensuring a safe and reliable system. I hope this breakdown of Class 2 circuits was helpful and cleared up some of the mystery behind all that low-voltage wiring. It's a really smart system that makes so much of our modern technology possible and safe. If you found this video informative, please give it a thumbs up and consider subscribing for more deep dives into the world of electrical systems. Let me know in the comments if you have any questions or what topic you'd like to see covered next. Thanks for watching, and stay safe out there.